Hello. So today we'll be doing an overview of how to approach Maths Paper 1. So, okay. So I'm going to illustrate this by going through Maths Paper 1, November 2018. So in this video, I'm just going to give you a brief summary of how to approach um, all these questions for Paper 1. So because it will be a brief summary and a high-level summary, may you please have like a page in front of you then to take notes fast. So let me start here. Okay, so let's start ka November 2018 here. It starts ka question 1. So question 1 for question 1 for okay, so question 1 for the paper will be as follows. Okay, so firstly, question 1, they will ask you algebra. So I'm gonna go through the type of questions that they may ask you for algebra. So the first thing, king algebra, so solve for x, right? So let's do this question 1.1. So solve for x. So do you see more questioning like this question here? You look at like mark allocation first. Do you see it says 2 marks? So it means that solving this problem here shouldn't take like more than 2 steps. Ne? So in this case, what will you do? You'll say x is equals to 0, then 2x plus 1 is equals to 0, right? Therefore, x is equals to 0, then x is equals to negative a half for this one. So this is the first type of question they might ask you more like in a paper. So if like the brackets, mobile solve for x and like so you are multiplying one term. Do you see this as one term? So if this is the case, then you'll see mark allocation thing will be 2 marks. All you need to do with this one is just equate these two brackets to 0. So x must be equal to 0, and even 2x plus 1 must be equal to 0. So that's your answer for the first one, 2 marks. So this is the first type of question they might ask you. If maybe it's like solve for x and you have to multiply it out, you can multiply it out and is equals to 0. In this question, because you are solving for x, you won't multiply it out because this is like the factorized form, and this is what you want. So you're gonna just equate x to 0, let this bracket to 0. So if you see a type of question whereby for question 1, I mean, they say maybe let's say a bracket multiplied by a bracket is equals to 0. A bar solve for x. In that case, you'll just equate those brackets to 0. I hope you get me there. Let me show you another thing. Go 2017. So that was a 2018 paper. 2017. Do you see here? They have the same example, like I told you, get 2 marks in. Then get bracket multiplied by a bracket is equals to 0, solve for x. What you do in this question, you won't multiply out this bracket because you are solving for x. This is the step that you want, right? So get step so thrilling. After you had like a trinomial, this is the second step you do like to get from a trinomial or solve a x. So when you are in this step more, you just equate these brackets to 0. So 2 minus x, 2x minus 3 is equals to 0, and x plus 7 is equals to 0. Then just solve for x normal. So I'm gonna go back to the 2018 paper. So that's the first thing. Ne? That's the first type of question they have more. Yeah, so you have 2 marks at the bracket. So you see, all you just do is give answer and so 1.1. You just equate these things to 0. let this bracket to 0, then solve for x normal. I hope that one you get. So that's the first type of question. Let's move on. The second type of question is if trinomial. So they give you a trinomial, then they tell you how to correct to 2 decimal places. If they say correct to 2 decimal places in the test, then you know already here that you should use the quadratic formula. Why? Because that's the only way you can get like 2 decimal places, because you have to use a calculator. If they say correct to 2 decimal places, then why it's from the get-go, or you must use a calculator for this one. So how do you use a calculator to solve this thing? By using that formula, quadratic equation. I guess this is a quadratic value equation. So because we are solving for x for this quadratic equation, the first thing you're going to do is going to say x is equals to negative b plus minus the square root of b squared minus 4ac over 2a. Then you just substitute those variables inside the equation, then you get the answer for the 2x's. This is how you approach a question. You're corrected to decimal places every time. So you're corrected to decimal places. You don't even waste time for. First thing to it, you make sure the equation is in the general form. Then put that formula down, insert those variables into the formula, then solve the equation. Then make sure you correct that 2 decimal places. So when you see correct 2 decimal places, you know already quadratic formula for question 1. Let me show you how big question 2. So you see 1.1.2, it's the same thing. This is the general formula thing, quadratic equation. Then they say leave your answer correct 2 decimal places. You know more. You use what do you call this? The quadratic function. So then just substitute. Let's just check for 2016. So for all of these papers, it's the same format. So you see for 2016, they started Kion. That one, you leave, correct your answer 2 decimal places. So even here, you're just going to start the formula, substituting the formula and get your 2 answers. That's if they say correct 2 decimal places. So that's that type of question. So let me show you the answer here. So 1.1.2, I want. They just put that formula, then substitute it to the formula. Like B is 2, C is -6, and A is 5. And you get the answer. Okay. Let's move on. That was the second type of question. Yeah. Then the third type of question, okay, it's like this one, 1.2, 2016. So this question A. This is a normal trinomial. This is a normal trinomial. So what you're gonna do is create 2 brackets, obviously, for solvent. So something like this. So this one not it's a normal like you normally do. I get a x squared, then 80 is equals to 4 times 2. So it's the same as 4 times 2. 4, 2. Here it's a positive. So this sign you're gonna put it in both brackets. Yeah. And -2 minus 4 is -6. So right to the bracket is perfect. So you can just after here you equate this to 0, then you solve for x normally. So this is the third type of question you may have. So this is a normal question. A normal, I mean quadratic form, maybe an equation. So solving a normal quadratic equation, this one. So the first one, so did you see in our first question, this one, it had like let me show you this one, this step. Yeah, did you see it was that same step that I made at the bracket C2, so that x minus 4 and multiplied by x minus 2. So like I said, if more they give you this type of question, you'll see 2 marks. Why? Because step will say they already did it for you. Whereas in that, you see this one, they're giving you 3 marks because you still have to do step C. So that's the third type of question. Now let's move on. The fourth type of question is if there's a surd. So if something like this, if there's a surd, so something like this. So a surd, I mean like root sign. So what do you wanna do? Like how wanna assert? The first thing we wanna cancel out this surd because we can't do anything square root. So what are you gonna do? We're gonna take this 3 to the other side, right? Then what's gonna be left is the square root of x minus 1 is equals to x minus 3, right? So it will be square root of x minus 1 is equals to x minus 3. So then here to cancel out Z A, we are just gonna square both sides, right? Then this thing at so it's gonna be x x minus 1 is equals to, then you just expand this thing, so multiply it out, so it's equals to x squared. Don't forget multifoil in there, so these two brackets, so it's minus 6 x, then plus 9. Then from here on, you just solve for x normal. You're gonna get like two answers to x name. So let me show you the answer. Here go memo once. Let me show you the answer. So yeah. No, that's not the answer. Okay. Okay, you get 2017 paper. Okay. So yeah, for that one, I get one memo thing. So for this one, continuation here is just solving for x normal. Then what do you do every time there's a surd? Every time there's a surd. So this one you're just gonna continue onwards, Molly, and get your two x's, your two answers, right? But every time there's a surd, please check your answer. So you'll get two answers. Then those answers, substitute them back into this equation and see that how substitute x more, lay more. Do you get the same answers both this side and this side? Because if there's a set, then some of your x's may not work. So you might get maybe two answers, maybe 5 or -2 maybe. Then when you substitute them here, like answers on both sides, then you know that that x value it's not applicable. So you are just gonna say, maybe let's say you say x maybe x is equals to 5, not something substitute together. Then this is how you're gonna show it. Like let's say 5 feel high, like you got two answers, you want to 5 and like it doesn't work. So you're just gonna say x must not be equal to 5. Then or NA. So NA just means this thing is not applicable, this one. So that's how you do an surd. So every time you see a surd, you wanna cancel out like that surd. Ne? Then I'll go here to A, yeah, 1.4. Ne? this is, yeah, another like type of question that you can find. Good thing. Ne? So this one ne, is if you have two wabanamo, you have two sets, you see. And in this question, there's no way like you'd cancel out like one set. Like a multiplier by babies and root king two square root 2 plus square root 2x plus 5, even though you multiply it like on both sides, this thing won't cancel out set a one. Like I isa like that side, it won't cancel out this set because there are too many terms. In order to cancel out like a set, you need I wanna check out this question here. You need that set to be in one side so that o kgone go square. How fetch square, then you can continue. But in this type of question, do you see that there's no way this side it can be like one term because it has to be one term. So if this is not possible and one square root so, ne, then this is called like a lead type of question. So you have to change. So if that's the case, ne, I wanna check a square root. So it's a lead type of question. So what is a lead type of question? So you have to change one of so one of like a term, you have to change a term into another variable so that ubereka easy that's one. I'll show you what I mean. So 1.4, you're gonna approach it like this. You're gonna say let square root 2x. So that's the another type of question, get let type of question. So where you change variable a one. And this happens if you see two things. I'll tell you when you use this let type of this thing. So you can just say let this thing. So yeah, let square root 2 plus x 2x plus 5 equals y. So this whole thing here we said is equals to y, and this whole thing here is equals to y, right? So what does it mean for us? So it means that y minus 3 over y is equals to 2, negative 2, right? Then you multiply y on both sides, so it's going to be y squared minus 3 is equals to negative 2y. Ne? Then from here you solve for y, so you're going to get 2 answers to y. Then after you solve for y, so you're going to get 2 answers to y. Let's go to memory. I think you want to say good thing. So okay, here they let it horrible k, so they let this thing horrible equal to k. So you can make it to be equal to y, k, it doesn't matter because a variable is just in a placeholder for a number. So you can use any variable except x. Don't use x because x they already used it. Ne? So you can use any other variable except x. Then this is what they did, like same as me, then multiply out, then they solve for that y or k. So after Oscar, what was the question saying? Question says solve for x, but we solved for k or for y. So you have to substitute, I get more, we said k is equal to negative 3. So this is the same as saying in our example, y is equals to negative 3. And what did you say y is equals to? We said y is equals to that when we started, right? So you have to substitute that back. So square root 2x plus 5, yeah, is equals to negative 3. Then from there on, you solve for x normally. It's easier now to solve for x. So that's how you approach that type of question. Okay, that's a lead type of question. I'll explain to you how to identify it happy fast. So do you see? Then here, yeah, A no solution. Why is it there's no solution? Because even if a substitute, oh yeah, an answer like if you solve this thing here, you'll get no solution then. But the reason why let's like they didn't go any further is because do you see any number kamara square root must never be a negative, like it can't be a negative, so you can't get a -3 no matter what, it doesn't matter. Because if answer ya kamogare kaf you are negative, then this thing is gonna be it's gonna be no solution, so it's gonna be an error. Agree, maybe it's a negative inside the square root ke error, so that's why here they have no solution. Then here they calculated xn. Then don't forget xa, we substitute back to see if it works, because there's a set. Every time there's a set, you have to check if that answer works now, because it might not work. Né? Then let's go to let types of questions. So that was for sets. So sets, what do you do? How one of these sets? The first thing you do is check if you can isolate that set. If you cannot isolate that set, meaning we will monocyting one as one term, so that you can square it if I, then most probably that set question if fall under a let type of question. Now, not all let questions are set types. Ne? A let question is if, let's say, wanna like maybe in the numerator, there's sort of like a term that you can substitute for another variable. What I mean is there's a exactly identical term somewhere else. This and this are exactly the same. Ne? Then you know it's a let type of question, especially if one term more, it's in the numerator, then A1 equal to denominator, and then that, then you know that's a let type of question. Then the second let type of question is if baby like that term L, so that term L, ne, you can double it. So if let's say square root 2x plus 5, if let's say let's check if you don't have like example here or somewhere. Okay, they don't. Do you see for 2016 one? They had like this set type. You just have to take this thing that side. Then you can isolate this set. So you can do it the same way as I did year 2017. Mara because you can isolate it, you can't do it the same way. Then let type of question, like I said, on the bracket mona, like it has to be identical, like more lame. Then you know it's a let type of question. Then another let type of question is if that thing that you are changing, ne, like it has like another term going on, it has like double itself. I get double itself. I don't mean, okay, not double itself, like itself squared. The thing is, it's hard to illustrate without question ya thing on one. Mare, like there are two let types of question. Is if like numerator and E1 equal to denominating and they are exactly the same. And the second type is if they are exactly the same, but the only difference is just that one is the square of the other. Then you know how to let type of question. And a let type of question, X thing is very difficult to solve like normally. If you solve X normally, never will solve, then you know it's a let type of question. Yeah. So for question one, that's like algebra. So now let's continue here, got those types of questions. So we already did trinomial, bracket, surds, and let type of question. The next type of question it's the inequality. The next type of question is questions concerning inequalities. So if you see an inequality, so the first thing you do is to make sure This one that has an x squared, it's positive. So make sure that the a is positive. In this question, it was already positive, so you just have to take this 3x to the other side. So it's going to be 2x squared minus 3x minus 2 is greater than or equals to 0. That's the first step. So the first step is to make sure that this is positive. Then you take everything to one side. That's the first step. Then the second step is to get your critical values. So what are your critical values? So in this case, you're gonna take that 3x to the other side. So I was gonna give you something like this. Then right. Then from here on, you're gonna get two brackets the same way as you do a normal like trinomial. Get two brackets. We say this is greater or equals to 0. Then 2 x, then x minus, then 2 minus, and we go 1 plus, yeah. Then from here on, I get in a normal like equation, so we get x is equals to, so normal x is equals to, but this time do you seek inequality, so x is not equals to that. So what we get are called critical values. So author CV, then just do this thing normal. I'll solve for x. So x is negative half for the first bracket, or my critical values you use end, because they are critical values. So then it's positive 2. Then after you have your critical values, or draw sketch. So negative 2 will be somewhere here, 2 maybe here. This is just the mini sketch that you draw to illustrate it. Then, yeah, you draw a mini function using information. So why do we draw a SOR function? Because like I said, make sure A is always positive. That's why it's always like a smiling graph. So then critical values are these intercepts. So what happens now? Do you see they are saying solve for x again? Now, what does this equation say? It says give us the values of x, where this equation, so this equation is greater or equals to 0. So what is this equation? This equation is basically a graph. What graph? This graph area drilling, this mini one that you sketched in, right? So they say give us the values of x where this graph is. So this graph is what? Greater than or equals to 0. And how do you assess like graph? Using y values. So you're gonna assess this graph where this graph is positive. So where is this graph positive? It's positive after 0. So after y. So over this line, over this x-axis line, this graph is positive again. Then go class it's negative. So what I'm trying to say is graph emo, it color ever positive, 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 positive. This graph it's positive, positive. Why? Because the y values are positive here. Positive, positive, positive y values. Why? That's how we identify this graph. I get the positive. Then when it reaches here, graph A, it was 0 again, because y is 0 on the x-axis, y is 0. Then as you go class, you see y ever negative, because now it go class this line. So it's negative, negative, negative. As long as you look at class line, make it negative, negative, negative. Then high vitamin 2 ever 0 again. Do you see? Then ever positive again from 2 going onwards until infinity, until positive infinity, ever positive, positive. So we want you to give the values of x where this graph is above this line. So where is this graph above this line here, x-axis? It's from negative infinity, because do you see from negative infinity, this graph is gonna go up, 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 up until infinity. So you're gonna come from, so from negative infinity, you see where this graph is positive. So from maybe if, like, let's say x, it was maybe negative 1,000, this graph was still gonna be positive because it was gonna be this side of the x-axis. So then maybe negative 50 more, negative 10, still graph a positive. Do you see? Negative maybe 5, negative 3, graph is something positive. However, when it a positive until it comes here to negative 2, do you see where maybe maybe some, let's say after negative 2, yeah, let's say negative 1/4. Do you see negative 1/4? Never bereke more, because it is essentially in the negative portion now, because after negative 2, this thing becomes negative, this graph. Because it's really positive, 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 positive from all negative x values until this one, yeah, negative 2. Then from here it becomes 0. Then again, even negative, even not 0 again, then it becomes positive. So where are the values of x where this graph is above this line inner? So you're gonna start at this side. So the first answer key, x must what for this graph to be positive? X must be less than or equals to 0. Negative 1/2, I mean, yeah. For this graph to be greater than or equals to 0, x must be less than or equals to negative half. Why? Because if x is equal to negative half, do you see what this graph is equals to 0? Then if x is less than negative half, maybe let's say negative 1, then this graph is still positive. So that's how you write it. That's the first answer we're creating inequality. Or maybe it's x. So this side now. Do you see here it becomes negative, negative? Then from this point here, which is 2, ever 0, then even not positive, going towards like positive infinity x. So from this point, let's say x 1. Do you see if x 1, it's still negative this thing, because 1 I get x1 m. I get 2, it's here. So 1 is gonna be here. So this is gonna touch like this graph more. I get like if x1 is gonna touch it here, around this point, and that's where y is negative. So from this point more to going forward, this is where this graph becomes positive. So from this point more, 2 is 0 graph, going from 2 upwards about positive. So let's see about 10 more, then this graph still positive. If it was a million, this graph was still gonna be positive. If x was a million or 100, it was still gonna be positive. So what's the answer for this one? X must be greater than or equals to 2. Yeah, that's the answer, I think. Then you are done. So go on inequality. So king answer, x must be less than or equals to negative 2, or x must be greater than or equals to 2. Yeah, that's how you approach all inequalities. And there will always be an inequality type question now. So yeah, do you see 2016 banana on inequality KMO? One. Let's first step, like I said, make this thing positive. So you're gonna take this thing to the other side and take this one to the other side. Then we'll say inequality. Then even here, okay, this one A is positive, so you're just gonna take everything this side, then solve your inequality the same way that I showed you. Okay, so that's question 1.1. So question 1.1, those are the type of questions that they may ask you for question 1.1. For your let, okay, this one is not a let type of question, because do you see no a common factor, which is 2 to the power of 3 x, The let ne ke bua ka yone is if like you have something like this, maybe it was 2 yeah 6x, so 2 to the power of 6x plus 2 to the power of 3x. Yeah, if you have something like this is what I meant, Jorge. It's either you're gonna have two identical things, like two identical brackets, like more for let. And if they're identical, you want to more denominating in one term, then you want to it's a numerator in one term, then the one is gonna be a denominator in another term. So for this one, it is the second type of let question. If let's say I want to 2 to the power of 6 x, then a 2 to the power of 3x. Do you see if runs are common factor, which is 2 to the power of 3x, then we won't like be able to solve this thing like more. More if runs are 2 to the power of 3x, we are gonna be able to solve it because something like 2 to the power of 3x. I get open bracket 2. Because I get on to 2 to the power of 3x, 2 to the power of 1 plus 1. You're into bracketing, right? So here you wouldn't use let type of questions. Why? Because you can't have common factor. So you get ref. So you can divide both sides by 3, then 2 to the power of 3x will be equals to 4. Then from here on, you can solve for x more. So this one is relatively easy. It's really easy if like these ones are the same. So you only use a let type of questions. Let type of question, I mean, when so so you have something like this. So if they are the same, there must be like one denominator, one numerator. Do you see these ones here? They are the same, but one is not a denominator and the other is not a numerator. They are both numerators. So you won't use a let type of question. If Nene saw, then it was like this. Let's say 2 to the power of 6x and 2 to the power of 3x. Then you're going to use a let type of question. Let me show you what I mean and why you use it. So do you see if 2 to the power of 3x Ryan's like as so as a common factor? Here, Nagotosala 2 to the power of 3x. Do you agree? I get Nagotosala 2 to the power of 3x, then plus 1. Do you see by taking out common factor 2 to the power of 3, you essentially didn't do anything because more bracketing is something 2 to the power of 3. So you won't be able to solve for x because how can I isolate? When you're solving for x, go look at isolate the x so that one equals to what. If you can isolate it, it becomes a problem. So for that type of question, Eli, if you saw maybe 2 to the power of 6x, like I said, that's what I mean. Like it's not identical to the other one, Mare. It is the square of the other one. Then you can use a let. Do you see what this one? This thing 2 to the power of 3, and like 2 to the power of 6 is the square of this. So 2 to the power of 6, it's like you said 2 to the power of 3 squared. If that's the case, then you can use let type of question. You can say 2 to the power of 3x. So you can say let 2 to the power of 3x, that's x, 3 to the power of 3x must be equal to k. Then what happens? K squared plus k. Then from there on, you're gonna solve for k normally. Then after it's a substitute this thing back. Let type of question you must substitute back because you're not solving for k. Question needs to solve for x. So in the end, don't forget to solve for x and show them correct answer. Okay. So yeah, that's basically 1.1. So that's question 1.1. Those are the different type of questions for 1.1. I hope for 1.1 you'll be okay, man, for test data. Let's move on. So that's the type of questions for 1.1. 1.2, it is simultaneous. Everywhere it's simultaneous. 1.2. One. The simultaneous equation. 6 marks nyana mahal. So simultaneous, what's the best way to approach a simultaneous equation? Firstly, you're gonna assess these two graphs, number one. Ne? Then by assessing these two formulas or these two equations, you're gonna see which one is easiest to work with. So do you see this one easier to work with, because you can just say x is equals to 2 minus 2 minus y, or y is equals to 2 minus x. Then after you substitute that x or y into the other equation, okay, then that way it will solve for x or for y. Then after you have the answer to x or to y, don't forget that you have to substitute back into one of those three equations that you have. So those two, so one of the two that you are given, or a equation that you made, the third equation that you made, you substitute it there to check what's the other variable. So this is what I mean here. Wabanamo, like I said, you're gonna assess these two formula equations and see which one is easiest to work with. This one is easier to work with. A complicated, you see, you can't isolate really x more easily. Mara, you can isolate a y. So they just decided to use y. So barely y is equal to 2x minus 2 minus x, I mean. Then they substituted the thing, like I said, by substitute. Then you get two answers to x. Then don't forget, this is not where you end. Because the simultaneous equation, if you get two answers to x, don't create two answers, letter y. So you have to substitute back to one of these equations. So they chose to use this one, the third one. Okay, substitute into any one of these three, it will work the same way. And they got these two answers. So 1.2 is simultaneous equation, and that's how it's done. Do you see in every paper a simultaneous equation? Lemo. Obviously, more you're gonna assess these two equations and see which one is easiest to work with. Obviously, key here by saying x is equals to 1 minus 2y, 1. Then Reakoi. Le, which bracket is easiest to work with? This one. So you can just say y is equals to, then you take everything this side. 1. Yeah, that's 1.2. Yeah. Then 1.3. So 1.3 will always be nature of the roots. Ne? So 1.3 is nature of the roots. So let me explain what roots are. Number one, ne? Roots of an equation. Ne? What are the roots of an equation? Roots are basically the x-intercept. So our roots, they mean x-intercept. That's what they mean, our roots. So nature of the roots means nature of the x-intercept. So in this case, they say the roots of the equation. So it means the x-intercept of the equation of f of x is equals to 0 are that. So they are telling us these are the x-intercepts. I get. Determine the value of m for which the roots will be non-real. So let me explain how you approach these types of questions. Now, so I agree we know the formula, this one. Yeah, negative b plus minus the square root of b squared minus 4 AC, sorry, yeah, all over 2A, right? Yeah. So, good. Do we agree that delta is equals to b squared minus 4A C. Okay, now let me explain what nature of the roots are. So when they say nature of the root, so they mean nature of the x-intercept, okay, because roots are x-intercept. Now, what do they mean when they say nature of it? They mean how do they, so how do we classify that root? Do you remember in grade 10 or grade 9, you did number systems again? Number systems is where you classify that number as either natural number, real number, non-real number, depending on certain properties that number has. I get it. So what I'm trying to say is that delta is the only thing that can change property of of maybe it's of intercept of an x-intercept. I'll show you why. Delta, I get delta is equal to b squared minus 4ac, which is this part under the square root in this equation. And this equation calculates value intercepts I get x. So in this bracket here, this is where you have delta. I get, and delta, this thing delta is the only thing that influences the nature of this root A, because this is the root, the nature of this root. So delta here in this bracket here is the only thing that changes the nature of this root here. So what do I mean? Let me explain what do I mean. Let's say more, I'm gonna write this thing out again, formula A in terms of delta this time. So again, x is equal to negative b plus minus, I get the square root of b squared minus 4 AC, ne? All over 2a. So we said this b squared minus 4ac get delta here. So I'm just gonna remove this and write delta because I wanna illustrate something fast. So we said this is the same as this, right? So now let's assess lentole and let's see what let me show you what I mean when I say delta influences the nature of the root. I get this thing A is the same as one of these two answers that you're gonna get from a normal trinomial or maybe it's a quadratic function or formula or equation. So maybe let's assess this. If delta if delta is equals to 0, what will happen? So if delta is equals to 0, what will happen? Do you agree that it will be 0 under a square root? So it will be square root 0. And what is square root 0? Square root 0 is equals to 0, right? So you're going to get 0 all over 2a. I get it. So now let's say a and b get number. A and b are numbers, obviously. They will be numbers. Low it will be a number. It's just that it will feel a 0 or delta. Do you see that if delta is 0, I get it normally, not or negative b plus this number all over 2a. So negative b number, maybe let's say it's going to be negative 5. Negative 5 plus 0 is equal to is equal to negative 5. I get it. Negative 5 minus 0 is equal to negative 5. I get it. So do you see for both x values, because we're going to say for the first x, I need first x not or negative b plus 0, which is value equals to negative b all over 2a for the first one. Then for the second one, not or negative b plus 0. So that number I got negative b plus 0. So do you see, because we are plusing and minusing 0, both of these x values are going to be the same, because we are essentially doing the same thing for both of them. So that's where they get that thing. Do you see when delta is equals to 0? What happens to this one? I get these are the roots. I get these things are the roots. So when delta is 0, what happens to the roots? The roots are what? Number one, they are equal, because that x is equal to that equal. So we have equal roots, number one, because those x's are equal. So we have equal roots. I get if it's 0, Okay. Not only are they equal, but you see that by doing, or I guess this is gonna be a normal number all over a normal number. So this one, it's A over B, so they are also rational because you can write them as a fraction. If D rational, you can't write them as a fraction. You can just write them as a decimal if D rational. So you can write it as a fraction, so they are also rational. Ne? Then yeah, they are also rational. I get. Then the last one is that they are also real. So obviously, if something irrational, it must be real, number one. I get. So they are real. It means that they real just means that they exist. One. And eventually they exist because after zero mode, you still have an x-intercept. So that's what happens when delta is equal to 0. So if question array prove that the roots must be equal, rational, and real, then you know to prove a delta must be equal to 0. So when they talk about equal, rational, and real, you know they meaning delta something is 0. So let me check maybe more if that's not the case. One here 1.3 array f of x is equal to 0 has this roots for which values of k will the roots be equal. One. So what does this question say? For which values of k will delta be equal to 0? Because when will this thing have equal roots? When delta is equal to 0. So for this type of question, we're just gonna take this thing maybe it's this thing and say 3. I gotta get delta. So, but you can just show them firstly by saying something like so you can say delta must be equal to 0. Okay, so you can just explain to them for roots to be equal. So you can explain good just make an explanation for roots to be equal, delta must be equals to 0. Then obviously what is delta? Delta is whatever it's under this root. So this must be equal to what? To 0. Then you just solve for k, then you really answer. This is how you're going to approach this one. So when they say equal roots, they mean value for delta must be 0 because that's the only way you're going to get equal roots, equal x-intercepts, which are equal roots. Then this one is real and rational, so it's not equal. So they are not talking about equal. So equal, how about equal? They mean 0. They mean delta something is 0. I hope now I want why. Okay, I'll go to another one here thing. That was when delta is 0. Now let's assess this thing further. So what happens if delta is negative? So delta is less than 0. Do you see if delta is less than 0, then you're gonna have a negative inside like a square root, which is no solution. It will give you an error. No solution, this one. So what does it mean? If there is no solution, it means that Pella can no solution for the whole thing. So no solution for the entire thing. So there's no solution for the roots if delta is negative. So what does that mean? It means that if delta is negative, they are unreal roots. Unreal roots. Why? Because they do not exist. You can't get a number for it. Or one. That's why they say they are unreal. And this number, it is an unreal number in or one. Even if you can say an unreal number plus a real number, it's an unreal number. So when delta is less than 0, it will offer a non-real one. So let's go to 18. I think whenever yeah, but will determine the values of m for which the rules will be non-real. So whatever is in the bracket, delta. And we say for roots to be non-real, this thing must be what? Less than 0. So you must say for baby tongue for this thing to give you non-real roots, delta must be less than 0. Then you just put, I get delta is whatever it's in the bracket, so you just put whatever is in the bracket more. So whatever more bracketing not bracket man, whatever that's under the third, I mean. Yeah. Then this must be what? Less than 0. Then do you see this is a normal inequality? Solve it the same way as you would have solved this inequality here. You're just gonna multiply this thing out. Number 1. So not over 16. Okay, Mara, I'll just go to solution. Solution D. Okay. So yeah, do you see? For an unreal root, this is what happens. Then they multiplied it out. Normal inequality. Normal inequality. You just use the same rules. So only more you're gonna calculate your critical values. Then after calculating your critical values, draw that sketch early. Then after assess where that graph is less than 0. So what they did here essentially, in between, I get the critical values they got here was it was 1 and 4. And they made M positive, you see. So graph so something along these lines. Yeah, then Moke 1, Moke 4. So what did they say here? This graph A must be less than 0, you see. So starting from negative infinity x up until 1, this graph is positive, like we assessed for that one, positive until this point. But we want where this graph is negative this time, not positive. So where is it negative? It's negative here. Line in. So mutlas line yeah, x-axis, that's where it's negative. So where is this thing negative level? Negative x must be greater than 1, right? Okay, here it's not x, it's m. They are using m this time, so we're careful. M must be greater than 1, right? Then more true. Do you see x must also be less than 4? So m must be less than 4. So answer, m must be greater than 1 or m must be less than 4. You can write it that way or you can write it this way. Still the same thing. This one means that m must be greater than 1 or less than 4. Yeah. So that's how you approach like that one when delta is like Barracan unreal roots. So delta negative. Let me continue nature of the roots. Then yeah. Okay. So now let's assess it further. If delta, obviously if it's negative, it won't work. So if delta is a perfect square, so it's a perfect square, what will happen? Let's say delta was 25, maybe, or 36. Those are perfect squares, I guess. What will happen? Do you see under that said, you're gonna get like a rational number. So you're gonna get something like 6 a rational number. But if let's say we something like square root 5 more calculating, you're gonna get any rational number. You will see number after comma I fail. Any rational number just means that you can't write that number as a fraction. So if the perfect square and square root, you're gonna get obviously a natural number, like number grand. Obviously, provided that is positive. If it's negative, obviously it won't work at all. It's just an unreal root. So it must be a positive perfect square. So what will happen if you have a positive perfect square to the roots? Number one, you will have unequal roots again. Unequal. Because if we grab a number here, let's say no 25 more as delta, create delta 25, then answer was gonna be 5. And a b minus 5 and b plus 5 is not the same thing. Minus 5 and plus 5 is not the same thing. Mare minus 0 and plus 0, it has the same effect. Mare minus 5 and plus 5, it doesn't have the same effect. That's why it won't be equal. So let's say b in a negative 2. It were negative 2 plus 5. Or when a negative plus 2, negative 2 plus 5 is equals to 3. But negative 2 minus 5 is equals to negative 7. So you won't have equal roots. These roots will be unequal, number one. Unequal. Unequal. Then what will happen? Answer will be a number, like a distinct number. Like a cascade any rational number. So it will be a rational number plus a rational number divided by a rational number. So everything is over rational, meaning you can write this thing as a fraction, and a value you can write it as a fraction because number is really more a rational number. So this thing will also be rational because you can write it as a fraction. That's why it's rational. The root starting will be rational as a result of delta. Then obviously because they are rational, they exist, so they will be real because they exist. You are gonna, as long as you get a number as an answer, then it is real. It means they exist. If you don't get a number, no solution, then it's non-real because there's no number exist. So this is when it's a perfect square. So what maybe real and rational. Yeah. So yeah, that's when it's a perfect square. Then when it's not a perfect square. So when it's just positive, but it's not a perfect square. So it's just, so delta A positive, but not a perfect square. So this time it's but not a perfect square. So so yeah, it's not a perfect square. Yeah. So what will happen if like this thing is not a perfect square and it's positive? The first thing, you are gonna get an answer here since this thing is positive, high negative. So if let's say square root like more 5, you're gonna get like numbers are filling on, yeah, an irrational number. So if you plus an irrational number, that number will still be rational or one. You won't be able to write it as a fraction, right? Marashable lesson. If let's say more auto an irrational number, it maybe 1 comma maybe 257 whatever is a filling. Do you see 1,257 what and negative 1,257 what is not the same thing? So which means the roots firstly will be unequal as a result. So unequal because number delta will have a different effect because it's plus or minus. If it's 0, it won't have a different effect. So equal more unequal roots. Then they must also be irrational. Why? Because number is one irrational number. An irrational number plus an irrational number, you still get an irrational number. So irrational just means that you cannot write this thing as a fraction, like A over B or 1. Irrational. Yeah. Then obviously, if you have a number, it must be real. So because you're still getting an answer here, calculating, even if it's a answer getting the decimal, because you are still getting an answer, it is real. If you do not get an answer in a calculator, then it is not real. Yeah, that's everything ka nature of the roots. Ne? So that's how you approach a question, yeah, nature of the roots. Yeah. Then essentially, that's question one. Question 1.4, if ever ba lebotsa yone, it will always be a level 4 question. So I won't go to it because there will be different 1.4. One. This one they asked it a level 4 question. Level 4 just means that it needs a higher level of thinking. So I won't go through it because it's not standardized. It's not a standard question. I wanna for 2016 and 2017 there was no 1.4. It was only for 2018. So sometimes they edit, sometimes they don't. Mare question one, yeah, paper one will typically cost around 25 to 30 marks. I expect at least like from this session for you, if like you didn't get like perfect, at least 20 marks for this section. Yeah. Then that is like question one. Question two, we'll continue it in the next recording.